Hope you enjoyed Christmas break. And it's time to jump right back into math. On page 109, let me move this just a little bit. Sorry if I'm shaking you around. On page 109, it's asking us to use estimation to see approximately how much volume is in this milk carton. And it has us measuring that in cubic inches. So the first thing we want to do is let's just think about what volume is. We know that volume is equal to length times width times height. So if I'm just doing a quick estimate, if I glance at my little carton, it's about 2 inches wide. So our length is about 2 inches. And then remember, in width, when we're talking about volume, width is like how deep, because it's wide this way, so how deep into the page it goes. Well, we've all had little boxes of milk. We know that they're almost square on the bottom. So and it's estimating, so we're gonna say about 2. And then with our height, our little boxes of milk are usually about 5 inches tall. So if we multiply, we have 2 times 2 is 4. And then 4 times 5 is 20. So each of our little boxes is about, or an estimated 20, and it has us dealing in inches. And remember, anytime we're dealing with volume, it is cubic inches. So each little carton would be about, or an estimate of 20 inches cubed. Okay, on page 109. Okay, we're still using estimation, but now it's asking us to estimate how much milk do different size groups drink in a day. And the first one it starts with is just you, so one person. So one person, most people probably only drink 1 carton of milk per day, maybe with breakfast. So the typical person, one person probably only drinks 1 box, and we said that 1 box was 20 cubic inches. That's what we calculated the volume to be a few minutes ago. Okay, now, it then asks your class, how many cubic inches could your class drink? Now, it doesn't have us using our actual class. It tells us that there are 25 kids per class. So if I had 25 kids per class, and each of those kids could drink about 20 cubic inches, then we would be multiplying 25 times 20. And remember, quick trick math, anytime you're working with a power of 10, which means it ends in 0, you can multiply the number parts and then add that many zeros. So 2 times 25, I can do quick math on that. I know that that's 50, and then I add the remaining zeros. So for a class of 25 students, they could drink about, or an estimate of 500 inches cubed. The next one says your grade. Again, they don't have us using our actual grade here at school. They tell us that there are 3 classes per grade. So if each class, we said, can drink an estimate of 500, and they have 3 classes per grade, we're multiplying times a power of 10, so we can multiply just the base number parts. 3 times 5 is 15, and then add that many zeros. So if there are 3, or if there's 500 ounces 3 times, then that grade could drink about, or an estimated, 1,500 cubic inches in a day. And then finally, on number 4, it says your school. Again, we're not using our school. It tells us that this school has 6 grades. This school has 6 grades. So if each grade could drink an estimate of 1,500, and we have 6 different grades, we're multiplying times the power of 10, so we can multiply just the number part. 6 times 5 is 30. 6 times 1 is 6, plus 3 is 9, and then we can add the powers of 10. So if there are 6 grades that can drink 1,500 each, then we would have that the whole school could drink an estimated 9,000. And the final one on the page asks us, well, what about 10 schools? How much could 10 schools drink? Well, we just said that just the one school can drink about 9,000 per day. So what if we had 9,000 10 times? So we have 9,000 10 times. Now we know that 9 times 10 is 90, don't we? Okay, and then we could add that number of zeros. Is that right? No, what did we do? We had already used this power of 10, hadn't we? So when we do quick tip math, we would have to think this has already been used, so 10 times 9 is 90, and then how many remaining zeros to be used? 1, 2, 3. So if one school could drink 9,000, if I had 9,000 10 times, it would be 90,000. So remember on quick tip math, remember you weren't just multiplying the 1 times a 9 in the first option that we did. You had already used the whole 10, so you multiply the whole and then add the remaining zeros, which would be 1, 2, 3. Okay, now it tells us that we always need to think about, and I say this all the time, is my answer reasonable? Does my answer make sense? Okay, if we have 1 million, it says estimate the number of days. So now we're talking about days. The number of days it would take each of these groups to drink 1 million cubic inches of milk. Okay? So if I have 1 million, now it tells us, it changes our estimate just a little bit in the textbook. It tells us that each school could drink approximately, let me see, I think it told us 100,000. Yes, okay. It said that each school could drink 100,000. So if I had 1 million and I was having to, each school can drink about 100,000 per day, and I'm looking at 10 schools. So if each school can drink about 100,000 per day, how much would be for 10 schools? So I would have 100,000 divided by 10, and then we would have the 10,000. So let's see. 100 divided by 10. 100 divided by 10. Well, 100 divided by 10 is 10, right? And I can always double check. So we're saying that it would take 10 schools, an estimate, or about 10 days to drink 1 million. And we could go backwards and multiply in that, because we did 100,000 divided by, or 100 divided by 10, because it said that each school could do about 100,000 per day. So, the 10 schools, excuse me, let me back up, because it changes on us. Okay, yes, if each school was drinking 100,000, and then we have 1 million, we would be dividing 100, 10 schools. If 10 schools could drink 100,000 per day, then it would take 10 days for them to be able to drink the 1 million. All right, and then it goes down to your school. Well, let's think about that for a minute. If it takes 10 schools, 10 days, 10 schools, 10 days. Well, if it takes 10 schools, 10 days, then that's about 10 times 10, right? So 10 schools, 10 days. So would it take one school about 100 days? Okay. Because if it takes 10 days for 10 schools, it would take 100 days for one school. 10 days times 10 schools, 100 days. And then it breaks us down into your grade. And I told us a few minutes ago that that this school has 6 grades. So if it takes the school 100 days and there are 6 grades, then it would take each grade 600 days. Okay, and then it asks us about your class. Well, it told us that there were 3 classes per grade. So if it takes 600 days for the grade, then that class, and we have 3 of those classes, it would take that class about, or an estimate of 1,800 days. And again, we'll stop and let's think, is that reasonable? Yeah, that makes sense. It's going to take, if it's 3 classes, it's going to take them 3 times longer to do it, right? So 3 times longer than 600 days is 1,800 days. And if we go back and think, is it reasonable? Yeah, I had 6 grades, and if it takes them 600 days, and I go back to just the whole school, which is all the 6 days, so 600 divided by the 6 grades would give me 100, and that was for a school. So then if they told me that it was for 10 schools, 100 divided by 10 puts me back at 10 days. Okay, and then finally, just you. Well, if it takes the 3 classes, if it takes each class 1,800 days, and I'm just one person, okay? I'm just one person. And it's asking us to estimate. So instead of going back and doing, okay, the 300, there's 3 classes, 25 each, so that would be 75, and then times the 6. Let's just think a minute. How much did they say altogether? They said, how long to drink 1 million? If we remember and look back, we said that just one person drinks about 20. So then if I divide my 1 million by the 20 that I could just drink by myself, 20 won't go into 1, so placeholder 0. 20 won't go into 10, so placeholder 0. But 20 will go into 100. 20 goes into 100 5 times. 5 times 0 is 0. 5 times 2 is 10, and then I subtract. And everything I would have left to bring down is a 0. So we can use our quick math option. I would go to my quotient. Remember, the answer is your quotient. And for every remaining number that I have left, I would put a 0. So if it's 1 million altogether and I can only do 20, it would take me 50,000 days to be able to drink 1 million ounces. Now, think you could do that? You think you could do that? I don't think I could do that. And let's see. How many days in a year? We just learned in science that we know we have 365 days in a year, right? So 50,000 divided by 365. And again, we're just estimating, so we know it won't go into 5. We know it won't go into 50. It will go into 500, and it will go 1 time, and then I would multiply and subtract. And all I would have left to bring down were some zeros. So if I'm just estimating, and I know that all I had, if I were to put some more numbers up here, they would either be 0 over or above, wouldn't they? I don't think I'm going to live over 100 years, so I don't think it's reasonable to say that I would be able to drink 1 million cubic inches of milk when I know that number is going to be over 100. Okay? So, we've seen how that we can quick trick math. If we had 375 times 500, we could multiply just the whole number parts. 5 times 5 is 25. 5 times 7 is 35. Plus the 2 is 37. 5 times 3 is 15. Plus the 3 is 18. And then we would add our remaining zeros. Now that wasn't a big number. Let's take it down to a small number. If I had 500 times 3, 500 3 times 500, so that we can really break it down. If I had 500 3 times, if I was just adding it up, I would have 0, 0, 5, 10, 15. Well, if I look at it as multiplication instead of addition, and I multiply my base number parts, 3 times 5 is 15, and I have 2 remaining zeros, so we still come out with 1,500. And then if we looked at that in reverse, if I said you had 1,500 cubic inches, sounds weird measuring milk in inches. I don't know why they did that in the book, because we usually measure our liquids in ounces. So, but we're measuring in inches. If I could do 1,500 cubic inches, and that was split between 3 classes, 3 would go into 1 no time, so placeholder 0. 3 goes into 1,500 5 times. 5 times 3 is 15. If we subtract, then we have nothing left to bring down except zeros. And our quotient ends up being one of the numbers that we were multiplying by. So we can see by looking at all of our numbers how multiplication and division are related. Okay, so that's it for this lesson. We're just dealing in a little bit higher numbers than we've been dealing with. We have been estimating. These aren't exact numbers. It was asking us to estimate. We were dealing with powers of 10, and we were either multiplying or dividing, and sometimes we could do either